Good afternoon, chemistry students. It's me, Mr. Cheney, with another brilliant tutorial. We've been working on labs that are in the Savas textbook. The one that we did starting Wednesday or Tuesday, I forget which, was this one right here, water, hydrogen, and gold, the states of matter. And so now we have a new one, and it's all about melting points for different solids. So here in Google Classroom is where you will find it. And we have a Google Slides set just like the other one. So you'll open up your Google Slides just like so, and you will see where we're at on those. I'm going to explain all this in this tutorial. So to get to the lab, go to Clever, you go to Savas EasyBridge. Once you log into Savas EasyBridge, you're going to click on the textbook title, which is the California Chemistry Experience. And you're going to see your assignment box, and I have assigned it as an assignment. It's called, what is it called? Something tool. So I'll show you once I get it up here. So it's called Tough Tools, so you'll click on that. I'm going to go the long way because it's a different screen when I click on that. So I'm going to go here. Let's see if we are here. Virtual Lab Tough Tools. So now we're set up, and I'm just going to read through how to get through this lab right now. This is the scenario section for Tough Tools. Cutting into solid pieces of metal at high speeds requires tough tools. The cutting tip must be hard enough to withstand high pressure without chipping. The friction involved generates a lot of heat, so the tip must withstand high temperatures without melting. So in this lab, virtual lab, we're going to evaluate the properties of 3 different solids to see which one might be the most useful for making high-speed cutting tools. So here's the Investigate tab, and so we're just going to go through the different materials and the tools that we're going to use for the virtual lab. And so the molecular interactions within each solid determine the solid's physical properties. So the equipment in the lab will be used to investigate the properties of a covalent network solid, a molecular solid, and an ionic solid. So those are the 3 types of solids we'll be working with. So we're going to select each of these items to learn about them. So we'll click on the materials first. We have silicon dioxide first. Here's the symbol for silicon dioxide. Here's the chemical structure. Looks a lot like carbon dioxide, just with a silicon carbon instead of carbon. And this is the type. It's a covalent network bond. And silicon dioxide, or SiO2, is found in sand and within quartz, which makes up approximately 10% to 20% of Earth's crust. Silicon dioxide is a covalent network solid. That's the type of solid. Strong covalent bonds link the atoms together in tetrahedrons, which are 3-sided pyramids. The regular patterns of atoms within the solid gives silicon dioxide a crystalline appearance. Now we're going to click on naphthalene. Naphthalene is, here's the chemical structure right here. It's a molecular solid. That's the type of solid that it is. Naphthalene is an inorganic, nonpolar molecule made of 2 hexagonal rings of carbon and hydrogen atoms. To form a solid, naphthalene molecules stack together, but there are only very weak attractions between them. This type of solid is called a molecular solid. Naphthalene has a very strong odor. This property makes it an excellent insect repellent. Round pellets of naphthalene called mothballs keep moths away from linens and clothes. And the last metal that we'll work with, or solid I should say, is cobalt chloride. And the chemical structure is this, and it is an ionic solid. Cobalt chloride, or CoCl2, is an ionic compound. Like other ionic compounds, CoCl2 forms a crystal lattice held together by electrostatic forces between positive and negative ions. These electrostatic interactions are generally weaker than covalent bonds, although they do reinforce each other. A lot of energy is needed to break the lattice apart. So normally blue when dry, CoCl2 turns pink rapidly when in a humid environment. This makes CoCl2, or cobalt chloride, useful as a moisture detector. When mixed with water, it dissolves to form a bright pink solution. Okay, so that's the materials we'll be experimenting with. This device right here, it's a conductivity tester. An electrical conductivity tester includes a battery, a multimeter to detect current, and 2 metal electrodes that can be inserted into various materials. The multimeter gives a current reading in amperes if the test material allows electrons to flow between the two electrodes. So 1 ampere is a large amount of current, so a reading of 0.01 amperes on a multimeter would mean that a solid substance conducts electricity fairly easily. If there is little or no current flowing through the circuit, the multimeter reading will be 0.00 amperes. And the last thing that we'll read a description of is this right here, the foundry. So a foundry is a cylindrical heat-resistant oven. Flames fueled by a propane gas heat the interior to extremely high temperatures. The material to be melted is put into a smaller vessel called a crucible, placed inside the foundry. The foundry cover has a vent to release exhaust gases. The crucible must be moved using tongs to avoid serious burns. This foundry is fitted with a digital thermometer that measures the temperature inside. During your investigation, place each solid into the crucible and then into the foundry for melting. The digital thermometer will show the melting point of the solid once melting is complete. Okay, so those are everything that we'll be working with. So now we'll go to the Analyze section. And for each material, we are going to place it with the multimeter to see if there's a current, and then we'll place it inside the foundry to see what the melting point is for each of these materials. Before we get started, let's go back to the slide deck. Slide number 2 is asking us to do a hypothesis, which is a guess. So based on this information for each of the 3 materials, which do you think is going to have the highest melting point, the lowest melting point, and the middle? So you're just going to type in high, middle, or low, and this is a guess. We don't know yet until we actually do the experiment. Slide 3 is where we're actually putting data. So here's a reminder that ionic bonds are a metal plus a nonmetal, and that covalent bonds are a non-metal plus a non-metal. And then we have a diagram over here that kind of shows all 3 types. So we have ionic bonding, covalent bonding, and molecular bonding. Okay, so let's do one of the materials just to show you how this goes. Go back to the lab, start with silicon dioxide, put it over with the multimeter, and the reading is 0. So I can go back to my slides, and conductivity right here is 0, so I've already put that. We know that it's a covalent network solid because it says so right here, covalent network solid, silicon dioxide. So those 2 things have been recorded. Now we're going to put it into the foundry to get that melting point. And so we'll reset, put this into the foundry, and we'll pour in, we'll seal the lid, and we're going to turn it on. So part of our slide decks are getting a screenshot for each of these melting points. So I'm going to get this melting point now that I've got it. That's for silicon dioxide. So press copy, and I've recorded it's 1710 degrees Celsius. So that's what I'm going to put here, and I've got to go find what the Fahrenheit is. So how I can look that up is 1710 C to F, and it'll tell me that is 3110, and that's where I got that number. And then my screenshot that I did is going to go right here. So silicon dioxide, I'll do Control V. I will resize so that it fits here. And that's it. So we'll fill out the data table for the other 2 materials, and then the last thing you'll do for this experiment is do the results. So slide 2 was your guess, your hypothesis. Slide 5 is the actual melting point order, so which one ended up being the highest melting point, the lowest melting point, in the middle. And that's it. That is the lab. We'll be doing that in class. I'll be around live to help. This is for people who need additional help if you weren't here. I will see you back in class.